if we're ending up with no solution, okay, that means that something's going to have to run into a problem this time, okay? Now, we're going to start it the same way we kind of did yesterday. We are first going to draw a pretty picture of these. And again, we're assuming that I can create a triangle, so that's how I'm going to draw it to begin with. So I'm going to have my big A is 85 degrees. Then remember that the side directly across from that has to be our little a. So I have big B over there. Yes, no big B. Okay. And then I'm going to make my 25 be down here. So I have side, angle. Are we all okay with that? Alright. Now, which variable is the only variable that I have enough stuff to create a full fraction with? A. Okay, so I have to start with my A over sine of A. And then, what's the only other thing that I have information on? B. But this time, what are we given? The little one, which means I have to solve for the big B, which is a angle. So that's one of our big differences is that for side angle, we have to start by solving for an angle first. And this time, since I'm only given one angle, I can't just subtract. Are we all with me there? Alright, so then we're going to plug in. So I have 15 over sine of 85 equals 25 over sine of big B. Yes? Now we're solving for big B. Where is big B currently? In the bottom. Do we want it to be in the bottom? No. So, can I flip my fraction? Am I allowed to do that? Yes, as long as what? I also have to flip the other side. So we're okay to flip it as long as I flip both sides. Yes? Okay, and then it's going to look pretty similar to what we did yesterday. I'm trying to get big B by itself, so what do I want to do?
Multiply by 25.
Okay. Now, the only big difference here is that we were able to stop right there because we just had a little b, okay? But now I have a big B. Where is that big B located right now?
After the sine. After the sine.
After the sine. So technically it's inside the sine, right? Because sine is an operation, okay? Now, is all of this fun stuff going to be something on my unit circle? No, right? Because that's how we did our trig equations is once I get sine by itself, then I go, oh, what angle gives me this, right? This is not going to be a nice, pretty number. We agree with that. So remember, what undoes a sine if I can't use my unit circle? So those are my reciprocal. Yeah, it's going to be arc sine, or remember we also call it sine inverse. So I'm going to take sine inverse of both sides, and then that'll give me what my big B has to be. Yes? And remember that that's a button on our calculator. Agreed? So we can just type all of that into our calculator. Usually, and remember we need to be in degrees because our 85 is in degrees. What do we get? What do we get? What does our calculator say? It does. Which mine says undefined, okay, which is what Desmos is going to say. But remember that arc sine is basically going backwards, right? So let's think about for our sine graph. Remember, what do our y's have to be in between? What's our max and our min for sine?
1.
Yeah, I go from -1 to 1, yeah? And remember, if arc sine's going backwards, that means that the stuff on the inside of arc sine also has to be between -1 and 1. Well, if I just type in that inside stuff, I get 1.66. Is that bigger or smaller than 1? Bigger, which is why we have an issue here. And we're going to get domain error or undefined. Which also makes sense because what did we say we should run into?
No solution.
No solution, some sort of problem, right? And so basically what it's saying is that this has to be the angle, right? Just doesn't work. That this side length is not big enough for me to get an angle that's gonna work there. Okay? So this is no solution. So at that point, we can just say there is no solution.
How do you know to put the inverse?
So I'm solving for big B this time, right?
Yeah.
Because the little b was given to me. We with me there. Okay. I flipped it because I want it on top. And then I multiplied by 25 to get rid of it. Agreed?
Yes.
And this is very similar to like what we did last unit when I was solving. Remember from last unit, once I got my sine by itself, we used the unit circle, right? Except this stuff is not going to be on our unit circle, right? Because this like sine of 85 degrees is going to be some weird decimal, so I'm not going to get a nice pretty number here. But I still need to get rid of this sine. So if I can't...
So you're just looking for the B.
Correct.
Okay.
I can't undo it using my unit circle, so I have to undo it using sine inverse instead, because I need my big B to be by itself. Because my goal, again, is to be able to label this angle, right? And I need it to be by itself in order to do that. Except this time it didn't work, so we can't. Yes, no, maybe? Are we okay with that? Question? Alright. Ready to look at another one. So again, what might be helpful to do? Draw a pretty picture. So I'm given A is 20.5, little a is 12, and little b is 31. What are we going to have to start by solving for again? Huh? I already have 8.
Big B.
Has to be big B. Right? So notice that little a and big A is going to be what's given. Little b is also given. So we're going to start by solving, for big B again. But again, if I'm solving for big B, where do we want the big B to be?
Numerator.
In the numerator. So I'm going to flip both sides again. So if you want, you could just start from the beginning with the sign being in top. Okay? That's it. Then I can go ahead and plug in stuff. So what do we want to do first?
Multiply is right by 31.
And then what are we going to do?
Use the arc angle of sine.
Yep, use our arc or inverse sine again. So we get big B equals sine inverse of all of this stuff. And again, if there was no solution, this is the step that I would run into an issue with. Now, my directions tell us that there are 2 triangles, so we should probably get an actual number this time. But remember that this is the spot where we would run into issues if we had any issues. So we get approximately 64.783 degrees. y'all okay with that? Yes. No. Maybe. Sound good? Okay. Well, when we were doing our little doodads, right, with our pretzel sticks, yeah, when we had two solutions, okay, what was the difference?
One was obtuse and one was acute.
Yeah, right now, what is this? It's an acute angle. So my other option would have to be an obtuse angle. And so we get our second option, and a lot of times we will label it as like B prime, right? Because it's the second option. Does that make sense? We get that by taking 180 degrees and subtracting the first answer that we got. Because this was the acute answer. And now we need the obtuse answer. And what do we get there? Someone type for us.
115.271.
115.271 degrees. Yes? Okay with that. So we have two options. But it does ask us to find the two triangles, which means that I also need to solve for my other missing stuff. Or with me there. Which in this case is what?
C.
Big C and little c this time. Are we okay with that? Now, one of those is really easy to find now. What is that?
Big C.
Big C, okay. So, big C is going to be, remember, 180 minus big A minus big B. Yes or maybe? Okay, so what do we get if we typey that? Point seven.
17.
Sorry?
17.
17. Okay. Yes? But if I have two options for big B, that also means I'm going to have two options for big C. So that's going to be my C prime. And remember that big A was given, so that part is not going to change no matter what. So that stays A. But then we're going to subtract B prime instead. And that gives us our second option for C prime. So what do we get there?
44.223.
Yes? Now, this is the spot, okay, that if I only had one solution, I would run into an issue here. Okay, so 0 solutions, we run into an issue finding my first angle, okay? If I only have one solution, basically what happens is once I find my second angle, like the option for B, if we try to find the third angle with that second option, we get something that's negative, and which means it can't happen. And we'll look at one like that, but I'm just telling you, like, those are kind of the two places that tell us, do I have no solution, one solution, or since for us, this worked, we're gonna have two solutions. So what do we have left to solve for?
Little c.
Little c, okay? And so, we are given both things for little a, so I'm going to go ahead and use those. So I have 12 divided by sine of 28.5. We are solving for little c. And on the first one, the little c, the first one, I'm just using my original. And so just like yesterday, I'm going to multiply by sine of all that stuff. And what do we get? and we're in meters today. Okay? And then notice that really the only difference for our second option, so little c prime, is going to be that this bottom angle is going to be that 44.223. Yes? So you would just switch out this one for 44.223. And what do we get there? Okay, so those would be my second solution. And again, we had our first solution would be those two. So we have two different triangles that work. Which is again why we can't use this for congruency to say that two triangles are equal, because they're not necessarily equal. Because we have two triangles that would work for this side-side angle case. Questions on that? Alright. We're going to go ahead and stop there.